All right, so today we're taking a deep dive into something pretty heavy.
Literally.
Yeah, literally.
Black holes.
Those cosmic vacuum cleaners.
You know what I mean? Like gobbling up anything that gets too close.
Right.
But we're going deeper than that.
Uh-huh.
We're going to look at what happens when two of these monsters
Yeah.
collide.
It's gonna be good.
Full-on black hole collisions.
Right.
And our guide for this deep dive is an episode of the Astronomical Minute.
Awesome.
So,
Yeah, it's one thing to imagine a single black hole, but then you start to think about two of them
right.
caught in each other's gravitational grip.
Yeah.
Things get really wild. And the best part is this isn't just theoretical.
Right.
This is actually happening
Yeah.
out there in the universe right now, sending ripples through the fabric of space-time.
Ripples. Okay, so before we get to that,
Yeah.
let's make sure we're all on the same page about what a black hole is.
Okay.
Right. You know about the event horizon?
But, like, think about this. Not even information can escape.
No.
It's like the ultimate cosmic vault.
A vault with some serious pull, though.
Yeah.
I mean, remember we were talking about a region of space-time where the gravity is so strong
Right.
that anything that crosses that boundary,
Yeah.
that event horizon,
The event horizon?
it's gone forever.
Yeah.
Like falling into a whirlpool.
Okay.
But like with the dial cranked up to 11.
211, all right.
You know what I mean? To a level that we can barely even comprehend.
Okay, I'm getting dizzy just thinking about it. But now imagine two of these whirlpools,
Okay.
not just spinning on their own,
Yeah.
but like orbiting each other.
Uh-huh.
How does that even happen?
All right, so picture this.
Okay.
You got a densely packed star cluster
Right.
teeming with massive stars.
Okay.
It's like a cosmic mosh pit
Right.
where stars are just constantly jostling for space.
Okay.
When these massive stars die,
Yeah.
they collapse
Right.
and they form black holes. And sometimes these black holes can end up paired up,
Okay.
locked in this gravitational dance.
So it's not just some random encounter.
Huh.
They're like born into this cosmic tango.
Exactly.
Okay.
And this tango has a very specific choreography
Right.
over incredibly long periods.
Okay.
We're talking millions or even billions of years.
Wow.
They slowly spiral inward,
Okay.
losing energy
Yeah.
through something called gravitational radiation.
Gravitational radiation. Okay, that sounds intense.
Yeah.
What is that exactly?
So imagine these black holes.
Okay.
They're constantly sending out these tiny ripples in space-time,
Right.
like waves spreading out from a pebble dropped in a pond.
Okay.
Those ripples,
Yeah.
they carry away energy,
Okay.
and they act like a cosmic brake,
Interesting.
gradually slowing down the black holes and pulling them closer together.
So it's not friction or anything like that. It's
Right.
the waves themselves
Yeah.
that are pulling them in.
That's the beauty of it.
Wow.
It's a very subtle effect.
Yeah.
But over these vast cosmic timescales,
Right.
it has a profound impact.
Okay.
It sets the stage for an eventual and spectacular collision.
All right. So we've got these two black holes locked in this like slow spiraling dance,
Yeah.
getting closer and closer.
Uh-huh.
What happens as the tempo starts to pick up?
Oh, things are about to get interesting.
I bet.
So as the black holes spiral inward,
Okay.
their orbits accelerate,
Right.
and they start whipping around each other with increasing speed.
Okay.
And remember those ripples we talked about?
Yeah, the gravitational waves.
The gravitational waves, well as the black holes speed up,
Yeah.
those ripples become more powerful,
Okay.
more frequent,
Uh-huh.
carrying more energy away.
So it's like they're creating a cosmic symphony
I like that.
with the music getting louder and more intense
Yeah.
as the dance reaches its climax.
That's a great analogy.
Okay.
And those waves, those gravitational waves,
Yeah.
they're more than just a beautiful melody.
Yeah, okay.
They're messengers, carrying information about the universe's most violent events
Wow.
across billions of years.
Okay.
And now, thanks to incredible instruments like LIGO and Virgo.
Hold on, back up a second.
Check.
LIGO and Virgo.
Yes,
These are actual detectors.
they are.
They can pick up these cosmic whispers from billions of light years away.
Yes,
How?
they're incredibly sensitive.
Wow.
They can measure distortions in space-time smaller than the width of an atom.
That's insane.
It's pretty crazy.
That's how we're listening to these collisions.
Yeah, we're basically listening to these collisions.
Wow.
It's like having a giant ear pressed against the fabric of the universe.
Okay, that is officially mind-blowing.
Right.
So we're not just theorizing about these collisions anymore.
Yep.
We're actually observing them.
Yes, we are.
Through these gravitational waves.
Through these gravitational waves,
That's insane.
we're directly witnessing the echoes
Wow.
of these cataclysmic events. It's like having a front row seat to the most spectacular show in the cosmos.
Okay, I am buckled up and ready for the main event.
All right, let's do it.
We've got these two black holes spiraling closer,
Yeah.
sending out increasingly powerful gravitational waves.
Huh?
What happens when they finally collide?
All right, so imagine
Okay.
two whirlpools finally merging into one.
Okay.
But on a cosmic scale,
Right.
it's a collision of unimaginable power,
Wow.
releasing more energy in a fraction of a second than all of the stars in the universe combined.
That's insane.
I know, right?
Yeah.
And that energy
Yeah.
bursts forth as a surge of gravitational waves,
Wow.
spreading outward
Okay.
like ripples from a cosmic tsunami.
Wow, a cosmic tsunami.
Yeah. That's pretty intense.
I'm guessing that's not the kind of tsunami you want to be surfing on.
Definitely not.
All right, so in the aftermath of this collision,
Right.
what happens?
So a new, larger black hole
Okay.
emerges from the wreckage,
All right.
inheriting the combined mass of its parents, minus a tiny fraction.
A tiny fraction.
Yeah, that was converted into pure energy
Okay.
and radiated away
Mm.
in those gravitational waves.
Hold on, you said a tiny fraction of the mass is converted into energy.
Right.
That sounds like Einstein's famous equation,
Uh-huh.
EMC sphere,
Yeah.
coming into play in a big way.
It is.
Yeah.
It's a perfect illustration of the fact that mass and energy
Right.
are ultimately two sides of the same coin.
Yeah.
And in the case of black hole collisions,
Right.
the amount of energy released from that tiny bit of mass
Yeah.
is absolutely staggering.
Okay, I think I'm starting to grasp the sheer power involved here.
Yeah.
But, like, why should we care about these collisions?
That's a good question.
Beyond the sheer wow factor.
Right.
What can they tell us about the universe?
So by observing these collisions,
Okay.
we're not just watching a cosmic light show.
Right.
We're opening a window
Yeah.
into some of the most extreme physics in the universe.
Okay.
We're pushing the boundaries
Yeah.
of our understanding of gravity space-time
Right.
and the evolution of galaxies.
So each collision is like a cosmic laboratory,
Exactly.
giving us a glimpse into the fundamental forces
Mm.
that shape the universe.
It is.
Oh.
Each new detection
Yeah.
adds to our knowledge,
Right.
refines our theories,
Uh-huh.
pushes the boundaries of what we know.
Okay.
It's like piecing together a giant cosmic puzzle,
Yeah.
one collision at a time.
I like that.
But here's the thing.
Okay.
Some of those pieces
Yeah.
might not fit as neatly as we thought they would.
Oh, really?
Yeah. What do you mean?
Well, it might lead us to question even our most cherished theories.
Ooh, okay, now you've got me really intrigued.
Good.
Are you saying these collisions might be challenging what we know about physics?
Let's just say
Okay.
they're giving us a lot to think about.
All right, I'm definitely hooked now.
Good.
We've gone from cosmic whirlpools to tsunamis
It's been a journey.
to potentially rewriting the laws of physics.
Yeah. Where do we go from here? What other secrets are these collisions hiding?
Well, think about this for a sec.
Okay.
If energy is released during the collision,
Right.
doesn't that mean
Yeah.
that the new black hole
Mhm.
is actually smaller
What?
than the sum of its parts?
Really?
It seems kind of counterintuitive.
Yeah.
You'd think a bigger black hole
Right.
would equal a bigger mass.
Yeah. Where did that, like,
Right.
missing mass go?
Exactly.
Is our understanding of black hole growth, like,
What?
completely wrong?
It's not that our understanding is wrong,
Okay.
but these observations are definitely challenging us
Right.
to think about black hole growth in a new way.
Okay.
We have to account for this energy loss,
Right.
this conversion of mass into energy.
Uh-huh.
When we try to model how black holes evolve over time,
Yeah.
it's like trying to solve a puzzle
Okay.
where some of the pieces have vanished.
That's a good way to put it.
Right.
Okay, so I'm starting to see how these collisions are, like, shaking things up in the world of astrophysics.
They are.
You know, it's not just about confirming what we know.
Right.
It's about pushing the boundaries
Right. Okay.
and, like, potentially rewriting the rules.
That's what makes it so exciting.
Yeah. Okay.
And it's not just the physics of black holes.
Okay.
Remember, we've been using this analogy of space-time as a fabric.
Right. A fabric. Yeah.
Right. Well, if
Yeah.
that fabric
Uh-huh.
is being warped and rippled by these collisions,
Right.
what happens to the holes
Yeah.
created by the black holes after they merge?
Yeah. Do they just, like, stitch themselves up or something?
We're still trying to figure that out.
Okay.
You know, it gets into some really complex territory
Right.
involving quantum mechanics and the nature of space-time itself.
Yeah. That's a pretty big question.
It is a big question, and these are the kinds of questions that are
Mm.
driving the cutting edge of research in this field.
Yeah.
We're literally trying to understand the fabric of reality.
All right, now I'm officially feeling both incredibly small
Right.
and completely mind-blown at the same time.
I get it.
But, I'm realizing that we've spent a lot of time talking about
Yeah.
the mechanics of these collisions,
Yeah.
the nuts and bolts, so to speak.
Right.
But what about their role in the grander scheme of things?
Okay.
How do black hole collisions fit into the story of the universe?
That's a crucial question.
Yeah.
Remember,
Yep.
we're not just talking about isolated events here.
Okay.
Black hole collisions have profound implications for how galaxies evolve, how stars form,
Right.
and even how the universe itself
Wow.
came to be the way it is.
Okay, so zoom out for me a little.
Okay.
How do these collisions play out on a galactic scale?
All right, so think about the supermassive black hole.
Okay.
At the center of our own Milky Way,
Right.
it's a behemoth,
Yeah.
millions of times the mass of our sun.
Wow.
And guess what? We're
Right.
on a collision course with Andromeda.
We seriously?
Like a galactic fender bender?
Kind of.
When is that happening?
Don't worry, it's not happening anytime soon.
Okay.
We're talking billions of years in the future.
Great.
But when those two galaxies finally do collide,
Yeah.
it's going to be epic.
Mm-hmm.
Imagine
Yeah.
those two supermassive black holes drawn together by gravity,
Right.
spiraling towards each other
Yeah.
in this cosmic dance of destruction.
Wow. So it's like a black hole mosh pit on a galactic scale?
Pretty much.
I can't even begin to imagine what that would look like.
It would be amazing.
Would there be like explosions and fireworks?
Oh, it would be far more spectacular
Huh.
than any fireworks display you could imagine.
Wow.
Stars would be flung out of their orbits.
Oh.
Gas clouds would collide and ignite.
Right.
And those two supermassive black holes would eventually merge,
Okay.
sending out shock waves of gravitational energy
Wow.
that would ripple through the entire newly formed galaxy.
Okay, so not only are these collisions incredibly powerful,
Yeah. But they're also shaping the very structure of galaxies across the universe.
they're a key part
Wow.
of the cosmic evolutionary process.
Okay.
And who knows, maybe the seeds of life itself
What?
were sown in the aftermath of one of these ancient collisions.
Really?
Billions of years ago.
So by studying these collisions,
Yeah.
we're not just learning about black holes.
Right. Yeah.
We're potentially uncovering clues about the origins of life itself.
It's possible that's the beauty of astronomy, isn't it?
Right.
Everything is connected.
Right.
The smallest particles to the largest structures in the universe.
Yeah.
It's all part of one grand cosmic tapestry.
I'm starting to feel like we need a bigger loom to weave that tapestry.
Right.
But seriously, this is all so fascinating.
It is.
It's making me think about our place in the universe in a whole new way.
That's what's so exciting about this field.
Yeah.
With every new discovery, with every gravitational wave we detect,
Right.
we're pushing the boundaries of human knowledge. Right.
Peering deeper into the mysteries of the cosmos.
Yeah.
And who knows what wonders await us out there, just
Right.
waiting to be discovered.
Well, you've certainly piqued my curiosity.
Good.
I'm eager to hear more about what those future discoveries might be.
Right.
But before we get too far ahead of ourselves,
Okay.
I want to take a moment to really appreciate how far we've come
Yeah.
in our understanding of black holes.
It's amazing.
It wasn't that long ago
Right.
that they were considered purely theoretical objects,
I know.
the stuff of science fiction.
Exactly.
And now we're actually detecting their collisions,
We are.
listening to the symphony of gravity itself.
It's remarkable, isn't it?
Yeah.
And it all comes down to
Uh,
the power of human ingenuity,
Yeah.
our relentless pursuit of knowledge,
Yeah.
our desire to unravel the mysteries of the universe.
It's pretty amazing.
And with new and even more sensitive detectors
Yeah.
coming online in the future,
Right.
who knows what secrets we'll be able to unlock.
I'm on the edge of my seat.
Okay.
But before we dive into the future,
Okay.
I want to take a step back
All right.
and talk about one of the most important figures
Okay.
in this whole story,
Uh-huh.
Albert Einstein.
Of course.
You mentioned earlier that these collisions are helping us test his theories.
Right.
Can you elaborate on that a bit?
Yeah, sure. So remember, Einstein's theory of general relativity
Yeah.
predicted the existence of gravitational waves
Right.
over a century ago.
Wow.
But it wasn't until we started detecting them
Yeah.
from black hole collisions
Right.
that we had direct evidence
Okay.
to support his theory.
So these collisions are like a cosmic confirmation of Einstein's genius?
Exactly.
Wow.
And it's not just a one-time confirmation.
Okay.
Every new detection
Uh-huh.
allows us to test his theory
Right.
with increasing precision.
Okay.
under more and more extreme conditions.
Right.
It's like having a cosmic laboratory
Yeah.
where we can push the boundaries of physics and see how well Einstein's ideas hold up.
So is Einstein's theory like passing the test with flying colors?
Hell,
Or are there any like cracks starting to show?
that's the million-dollar question.
Yeah.
So far,
Yeah.
Einstein's theory has been remarkably resilient.
Okay.
It's consistently predicting the behavior of these gravitational waves
Right.
with incredible accuracy.
Okay.
But we're always looking for those tiny deviations,
Yeah.
those subtle hints
Right.
that might point us towards a more complete theory of gravity.
So it's like we're using these cosmic collisions
Yes.
to probe the very foundations of physics.
Precisely.
Wow.
And it's a quest that's driven by both curiosity
Right.
and this deep-seated desire
Yeah.
to understand the universe at its most fundamental level.
Okay. I'm officially blown away.
Good.
We've gone from black hole collisions to galaxy mergers
It's been a ride.
to the very nature of gravity itself.
I know, right?
I'm starting to think we could do an entire season
We could.
of the deep dive
Easily.
just on this topic.
Absolutely.
But for now,
Okay.
let's shift gears a bit
All right.
and talk about the future.
Sounds good.
What other mysteries
Uh-huh.
might be revealed through these cosmic collisions?
So imagine a universe where we can detect not just the collisions of black holes, but also the mergers of neutron stars.
Neutron star.
Yeah, those incredibly dense remnants of supernova explosions.
Okay.
Imagine being able to listen in on the birth pangs of a supernova,
Wow.
or even detect the faint whispers of gravitational waves from the Big Bang itself.
Okay, now you're talking about a whole new level of cosmic eavesdropping.
Right.
But seriously, like what kind of technology would it take to detect those fainter signals?
Well, we're talking about pushing the limits of engineering and physics.
Okay.
You know, we need detectors that are orders of magnitude more sensitive
Right.
than anything we have today.
Wow.
Some scientists are even proposing space-based detectors.
Say space?
Yeah, free from the noise and vibrations of Earth. That could potentially unlock an entirely new realm of gravitational wave astronomy.
So it's like we're building bigger and better telescopes.
Okay.
But instead of looking for light,
Right.
we're listening for these ripples in space-time.
That's a great way to put it.
Yeah.
And with each technological leap,
Okay.
with each new generation of detectors,
Right?
we're opening up a wider window into the universe,
Yeah.
revealing secrets that were once hidden from our view.
Okay. I'm starting to see how gravitational wave astronomy is really revolutionizing our understanding of the cosmos.
Yeah, it really is.
It's like we've been given a new sense,
Uh-huh.
a new way of perceiving the universe.
Exactly.
But amidst all this excitement about the future,
Yeah.
I want to bring it back to the present for a moment.
Okay.
You know, all this talk about black holes colliding and galaxies merging,
Right.
it can make the universe feel like a pretty chaotic and violent place.
It's true. The universe is a dynamic and ever-changing place.
Right.
But amidst all the chaos and violence,
Yeah.
there's also an incredible sense of order and beauty.
Really?
Yeah, think about it.
Okay.
These collisions, these mergers,
Right.
they're not random acts of destruction.
Okay.
They're part of a larger cosmic dance.
Okay.
A dance that's been going on for billions of years,
Wow.
shaping the universe as we know it.
So it's not just chaos, it's
Right.
choreographed chaos.
Exactly.
Okay.
And it's a choreography that we're only just beginning to understand.
Right.
But with each new observation,
Yeah.
with each gravitational wave we detect,
Uh-huh.
we're getting closer to deciphering the steps,
Oh, okay.
unraveling the intricate patterns
Yeah.
that govern the evolution of the cosmos.
Okay. I'm starting to feel a little more at ease with the idea of all this cosmic commotion.
Good.
You know, it's not just random destruction.
Well,
It's part of a grand design,
Yeah,
a cosmic ballet of sorts.
precisely.
Okay.
And it's a ballet that's still unfolding
Right.
with new acts and new dancers constantly emerging. Who knows what incredible surprises await us
Yeah.
in the next chapter of this cosmic performance.
Well, I, for one, can't wait to find out.
Me too.
But for now, I think we've given our listeners a lot to think about.
Yeah, we have.
Any final thoughts you'd like to leave them with?
Just this. The next time you look up at the night sky,
Okay.
remember that you're not just looking at stars.
Right.
You're looking at a universe teeming with black holes, neutron stars, galaxies colliding, and gravitational waves rippling through the very fabric of space-time.
Wow.
It's a universe that's dynamic, ever-changing, and full of wonder,
Yeah.
and we're just beginning to explore its mysteries.
Beautifully said. And on that note, we'll wrap up this deep dive into the world of black hole collisions.
It's been a pleasure.
Thanks for joining us. And as always, keep looking up